In this recording, we're going to learn some of the basics, or at least review some of the basics of probability. First off, some definitions. A set. Well, you can read it. This is how we write a set using this curly brace. A student once told me the way to write a set notation is something like this. Make an S, and then make a backwards S. And if you want to make the right curly brace, make a backwards S, and then make an S. So this is a set of specific items called elements. A subset would be a number of items contained within that larger set. So for example, the evens. Okay, complement of a set of data. So, or a set. The universal set, the set A, and complement means everything that is not in that given set. So you could represent it as complement of set A, or A with a little c as sort of a superscript here, not really an exponent, but where an exponent would be. And why don't you list out what you think the complement of set A is? Okay, so hopefully you identified those items. Okay, those are the evens. Okay, the empty set, the set with no items in it. So all prime numbers greater than 2. Well, there aren't any. Two sets that have no elements in common are called mutually exclusive. That's an important probability term for you to know. Okay, a set and its complement are mutually exclusive. I guess one thing I would think about if you're a card player is a card being a heart and at the same time being a diamond. Okay. True or false? So true, right? A card set and its complement cannot be mutually exclusive. Finally, true or false? Soccer and tennis are mutually exclusive. Well, that would mean they have no elements in common. Well, that's not true, right? Casey and Drew play soccer and tennis. So that would be false. And lastly, a little notation here. Union. Well, we saw this when we were looking at our interval notation. Union is represented by a U, and it's like an OR. If you just want to think of union as OR, all right, that's anything that's either in soccer or in tennis. Well, of course, that's all the names you see here. Intersection is an AND, or think of it as both. All right, so it's got to be in both sets, and of course, that's the green area, Casey and Drew. Next, we have some probability definitions that correspond to experiments. So please read and then play the recording when you are ready. Okay, so hopefully you took time to read these. If not, please do that now. All right, so let's apply that to this particular experiment. What is the experiment? Well, why don't you consider what that is, what a trial is, what one particular outcome could be, list out the sample space, in other words, all the different outcomes, and then the probability of it coming out being an odd number. Why don't you work on all of those and then play the recording to review your answers. Work on A through E. Okay, so pause and work those out and then play. Okay, so hopefully you did that, and we'll just go over the answers real quick. All right, so just recapping here, the experiment is just to spin the spinner. That looks like this. What is one trial? Just one spin. An example of an outcome could be any of them, 1, 2, 3, 4, or 5. There it is in the sample space. And the probability of landing on an odd number, we divide the 3 odds by the total 3/5. So, basic definition here, the number of outcomes that fall in the event. We also call it like the desired outcomes, the things you want, like an odd number, divided by the number of total outcomes, right? And all probabilities must be between 0 and 1 inclusive. I'm not sure why that 1 is there, because it's asking you what they are. Meaning anything between 0 and 1, anything between 0 and 100%. All right, so what does a tree diagram look like? I know this is a lot of review. I'm hoping this is not new stuff for you. I know I've seen my son and daughter do tree diagrams in their middle school work. So setting up tree diagrams here for a theoretical probability, basically showing all the possible outcomes that could come out from a particular experiment or an event. So let's make a tree diagram for the outcomes of the sample space of flipping a coin 3 times. So something like this. Now, to list them out as ordered triples is something of this form. This is the example of an ordered triple. So how many are there? Well, we can see there's 8. It's all these endpoints of the trees, like the leaves. 1, 2, 3, 4, 5, 6, 7, 8. There are 8. And list them out. And where does that come from? It comes from 2 cubed, by the way. 2 to the third. So let's just list out all the triples. All right, so there you have it. Those are the 8 triples listed out as a sample space. And now let's get into some probabilities. So why don't you find the probabilities listed in part C and then play the recording when you've got them. Okay, so hopefully you took the time to do that. All heads, well, that only happens once over here. 1 out of those 8 times. Exactly 2 heads. Well, you can count them. There are 3 events. 1, 2, 3 times where that happens. Still out of the 8 total. And then all heads or all tails, well, that would be right here or right there, which would be 2/8. It doesn't really matter to us if you write it as 2/8 or the 1/4 or 0.25. Any of those forms is fine. Okay. Empirical probability is what happened due to an observation in the real world, actually carrying it out, something like that, actually carrying out the experiment. So I'd like you to read these questions A and B, play the recording when you've got answers. Okay, so hopefully you looked at the number for preferring soda B, so that's 24 out of 53. In terms of a decimal, we're going to look at 0.45. Not soda A. Well, there's a couple ways we could go about this. We could count the B's and C's, add those up and divide by 53. Or we could count the A's and subtract from 1. That's like a complement of the event. So that's the way I'm going to do it. It can be done the other way as well. So 1 minus 18 53rds works out to be 35 53rds. Well, that would be the same thing as if I added up 24 and 11 and got 35. And of course, that works out to be around 0.66. All right, now we're going to consider some kind of traditional coin tossing, die rolling outcomes from an experiment. I want you to list out the sample space, and we'll call that S for the sample space. Listing out all the possibilities. So I'll get you started. One possible outcome to a coin, and then a die roll would be something like, could be head followed by a 1, something like that. Would you please list out all the possible outcomes to this experiment? Okay, hopefully you did that. Okay, now in part B, it's asking us to write a specific set of ordered pairs. That set that corresponds to getting a tail followed by an even number. Let's call this A. Okay, so go ahead and play the recording once you've got that set listed out. Okay, so hopefully you listed that. Something like this. Okay, that's the set. Now in part C, it asks us for the complement of that set. It's going to call that B, which is equal to the complement of A, which is every other pair. All right, now that we've listed out all those sets, it's going to ask us for some probabilities. So this notation here is just saying, what's the probability of a particular event being an event in A? So that would be 3 out of the 12 possibilities. So that's just a 3/12. And probability of B occurring, well, that would be the 9 out of 12. And these have to add up to 1. Notice how this is 0.25, and this is our 0.75. I like to put a leading 0 in there. These have to add up to 1 because they're complements. Now finally, we're going to revisit Venn diagrams. So this is something you've seen in other grades. A Venn diagram is, as it says, it's a diagram consisting of circles. Could have more than 2 circles, a way to show relationships. And we're going to find it useful when we get into some more complex conditional and compound probabilities. All right, so to set up a Venn diagram for this scenario, we like to start with a box that illustrates like the universal set, like everything. And we've got a 6-sided die, pretty standard, and A is going to be a number greater than 4. B is the complement of that set. Okay, so our A and our B can be represented with circles. Often they're interlaced circles like we saw with tennis and soccer. These aren't, so hopefully you can see why. It's got to be greater than 4, so that would be, what, 5 and 6 only? Numbers greater than 4. And the complement is the others, so the possible sides of a die that aren't 4, so 1, 2, 3, and 4. Now, it's not always that we list out the actual events, the sample space. It's sometimes that we just list out the number of ways that can happen. So we might just put a 2 here and a 4 there. But in this case, we did list out the sample space like we did back here with soccer and tennis, where we didn't list the number, we listed the specific people that were in those sports. All right, so the probabilities. Well, the probability of A occurring is 2 out of 6. And again, you can leave it that way, you could simplify or provide a decimal. Probability of B occurring, 4 out of 6. Again, these are complementary events, so they have to add up to 6, 6, or 1. And as it says here, what is the probability of A plus B? Well, 6, 6, or 1. Thanks for watching.